Hi, my name is James Kazanjian, and I'm representing Senior Design Team 14, and this is the final prototype for the renewable energy speed bump. We will start with the input portion of the speed bump. When a car drives over this speed bump, as you can see, it will compress. The piston shaft will compress inside the piston chamber, pressurizing the air inside of the chamber. The air will be pushed out through this check valve and will be stored in an air tank. When the system restores due to this spring, air will be pulled through this fluid conduit through this check valve and will restore air to the piston chamber. When the air is pushed out of the piston chamber, it will be stored in this pressure tank until it reaches the maximum pressure that the air tank can handle. The air inside of the air tank will be pushed through a pressure regulator to a diffuser. The air will be pushed through this diffuser and will spin this lift-type turbine. The lift-type turbine is connected to a shaft, as you can see, and which rotates a permanent magnet alternator, which is where the energy generation from our system will be produced. As you can see, on the other side of the permanent magnet alternator, we will be testing the voltage that it can produce through this voltmeter. In real-world applications, we will be storing the energy from the permanent magnet alternator inside of a battery or pushing it back through the grid. For testing purposes in our project, we will be testing individual components of our system. So, we will be testing the diffuser and air-type turbine and the permanent magnet alternator and how much energy can be produced from that portion of the system. We will also be testing the spring for its restoration time and its load capacity. And we will also be testing the pressure buildup that we can obtain through our pistons. That is our final prototype rendering video for Senior Design 14. And like I said before, this is the renewable energy speed bump. Thank you very much.